looking at our new unit, which is on patterns and sequences. I am on page 11. In a few minutes, we are going to need a couple of small, about 1 inch, 1.5 inches of strips of paper. It does not have to be in color, and we'll talk about that in a few minutes. So have your scissors and a sheet of paper ready. Okay, there's many types of patterns, and the most famous type of pattern that you're going to see in any lesson and textbook is the Fibonacci sequence. The Fibonacci sequence is seen in nature. For example, a sunflower or a pine cone. And so let's look at the Fibonacci sequence. It is 1, 1, and then you add 1 plus 1 to get 2, 1 plus 2 to get 3, 2 plus 3 gives me 5, and 3 plus 5 gives me 8, and so on. And so any lesson with patterns will always begin with a Fibonacci sequence. In this lesson, we're going to look at arithmetic sequences, geometric sequences, and other. An example of other, of course, is a Fibonacci sequence. So let's go ahead and begin with a definition of a sequence. Let's go ahead and begin with a definition of a sequence. Okay. Using my dictionary. Okay. I went ahead and wrote on my dictionary that there's two types, arithmetic and geometric. So a sequence is a set of numbers or a pattern following some order or rule. Okay, let's write that down. So a sequence is a set of numbers that follow a pattern or rule. Okay. In the example they give us in this sequence, it's 1, 3, 5, 7, 9, and 11. Okay. 1, 3, 5, 7, 9, and 11. So let's look at this sequence and see what's happening here. I want to know, what is the rule? What is happening? How do I go from one number to the other? So we call that number the difference. So let's go ahead and look. We get the second term on the right, and I'm going to subtract it from the number to its left. So 3 minus 1 gives me a difference of 2. Now let's go ahead and try that with another set of numbers, and let's see if the pattern is consistent across the numbers. So let's try 7 and 5. So if I subtract 7, which is on the right, minus 5, which is on its left, I get 2. Okay, seems to be like the pattern is holding. So let's double check. What this means is my rule is plus 2. If I were to go from 1 to 3, I'm adding 2. 3 to 5 plus 2. 5 to 7. So it's 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. And 7 plus 2 is 9, and so on. And so we are adding plus 2. That plus 2 is called the difference. So this term, this sequence, is arithmetic. Okay, so let's define that. An arithmetic sequence is when you add or subtract to find the next term. So the rule for this problem, add 2. Okay, now there's different types of patterns. Look at this one. You remember these. So we just did this problem right here in which we said that the rule was add 2. Remember these type of patterns, which we did perhaps in elementary, where you have the lower part of the triangle, the upper part, and you try to find the pattern. Perhaps there is a circle, square, and the elementary students are trying to determine the pattern. Okay. Oh, let's highlight our term, arithmetic sequence. So we have sequence here, and then arithmetic sequence. So let's go ahead and look at a geometric sequence. So in a geometric sequence is when you multiply or divide to find the next term. Okay, so let's look at an example. 3, 6, 12, 24. And usually in these type of problems, they will say something like, find the next 3 numbers. Okay, so we are given some type of sequence and we have to determine what it is. Now my first instinct is to try to subtract. Let's look at it as an arithmetic sequence. I get my second term and I subtract it from my first term. Okay, 3 plus 3 is 6. But when I try it with the next term, remember you always try it more than once. If I subtract 12 minus the number on its left, notice the pattern does not hold because 12 minus 6 is 6. So this is not 3 plus 3 is 6. 6 plus 3 doesn't work. So this is not arithmetic. Okay, let's try geometric then. We call that number the ratio. So what I'm going to do is get the number on the right and place it over the number on the left, and I divide. So what we're doing here is we are multiplying by 2. 3 times 2 is 6. Let's try it again for another 2 set of numbers. Let's try the 24 over the 12. 24 divided by 12 is 2. Okay, so our pattern is, our rule is times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And we can find the next couple of numbers. Okay, so in this case, R was 2. So here's 2 very basic examples of arithmetic and geometric. In an arithmetic sequence, we add to find the next term. 1 plus 2 is 3. 3 plus 2, that's an arithmetic sequence. In a geometric sequence, we multiply or divide to find the next term. Okay, here's an example, another example of an arithmetic sequence. Let's try this one in our notes here. So I have 2, 5, 8, 11, and 14. And let's find the next term. Okay, I subtract 5 minus 2, and I get 3. Let's test it again in another pattern, in another 2 sets of numbers. Let's do 11 and 8. 11 minus 8 is 3. So it seems like my pattern or my rule is plus 3. So 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So if I were to find the next number, it would be 17. So this term is arithmetic. Okay. There it is. Okay. Geometric sequence, we've looked at that example already. And we call that number that you're multiplying is called the ratio. So where's our example? Here we go. This is called the ratio. And D is called the difference. Okay, let's do one that has negatives. Find the next 3 terms of the following sequence. So I have 3, -3, -9, -15, so on. Okay. Let's go ahead and subtract. You get the number on the right minus, I'm going to put parentheses, see if that helps you, minus the number on its left. Okay, so the number on the right minus the number on the left. So -3 minus 3. So -3 minus 3 is a -6. Let's see if that pattern holds. I'm going to grab the next 2 numbers. I have -9 minus -3. So I have -9. Negative times negative is positive. The 2 terms are different. The 2 numbers are different, so I subtract and I get -6. Okay, try that one more time. I have -15 minus a -9. 2 negatives make a positive, and so I end up with -6. So let's follow our rule here. So our rule in this problem is to add a -6 or subtract 6, same thing. So -6. So a -15 plus a -6 -21 minus 6 again, and a -7 again. Okay. So that was a little exercise working with our negatives. I'm going to continue on the next page since I filled up page 11 to find the nth term of any arithmetic sequence with the first term a sub 1 and the difference d. Our formula, a sub n is equal to a sub 1 plus D times n minus 1. Okay, so we're going to use this pattern to find the nth term. So let's say they're giving me a set of numbers and they want me to find the 10th term, or they want me to jump all the way to the 100th term. So let's identify, let's see here. So n is the term that we're looking for, the 5th, the 6th, the 7th, or whatever. A sub 1 is the first term of the sequence, and D is the difference. Okay, now while we're at it, let's go ahead and write our other formula. To find the nth term, of a geometric sequence. With the first term being a sub 1, and this time of course we have the ratio. We have D for difference when you're adding or subtracting, R is ratio when you're multiplying or dividing. And our formula is a sub 1 times R raised, now I'm going to put that in parentheses. Okay, so let's highlight our two formulas. And there we go. Okay, let's go ahead and continue in this lesson, and we are going to work on a problem called the matchstick problem. But let's stop a second before I continue and let's plan. As a teacher, whenever we create our composition notebook, we do have to plan the layout of our lesson. And I see here that because I wrote kind of big, that I took up all of page 11 and a little bit of page 12, but the matchstick problem is going to need some space. So I think what I'm going to do is let's turn to page 13. We're going to work out the matchstick problem on page 13, and then when we need more notes, we'll continue. In your composition notebook, we never leave large gaps of blank paper, only because it's a waste. So let's go ahead and follow along. Now, some of you may even have page 12 blank if you write really small. But go ahead and let's go to page 13, and let's go ahead and work on the matchstick problem. Now, in this problem, they give us a series of shapes that were formed by matchsticks. Now, first of all, if you're doing this in your classroom, do not use matchsticks, obviously not, but this is from our textbook. So what I'm going to do is I'm going to use several sheets of paper that I just cut up. Now, I happen to have color paper. You can use white. I have about 10 of them. They could be about an inch. You don't want them super big. And I may even have to trim these down a little bit if I feel they're too large, because I want all of the matchstick problem to fit on one page, page 13. So if I'm going to glue these, they need to fit across the bottom. Okay, so what we're going to do is develop this pattern. Now let's go ahead and draw the way it is there. So I do have a square or four-sided figure here. And then I have two squares that are attached by a common side here. And then we have 3 and 4. Okay. So let's go ahead and count how many matchsticks would it take to create this pattern. Now in my classroom as an activity, I would have my students take the time. This would be a fun activity to do on a Friday afternoon. I could use popsicle sticks if I had some. maybe some chenille sticks. I don't know about coffee stirrers. They're a little bit thin. I kind of thought about that. So, or just good old-fashioned sheets of construction paper, which is pretty inexpensive. It's a little bit thicker. And so we'll say, okay, it took 4. Now, how would I build this figure right here? And so I'm not making a whole nother square. That's not what I'm doing here. So what I'm doing, if I attach it, then I add on, oh, look at that. Okay, and let's count them. So we said that the first figure had 4, and the second one had 1, 2, 3, 4, 5, 6, 7. Okay. Now hopefully by now you see the pattern, or the rule, should I say. In order to add another one, I'm simply adding on the 3 more right here. But let's go ahead and count them to develop our pattern here, our sequence. 1, 2, 3, 4, 5, 6, 9, 10. And so on. So then this one, I don't have enough to build it, and that's okay. And so if I were doing this with my students, I would have had a whole bunch of these little strips of paper. I would hand it to them in a little Ziploc bags, right? Don't have them cut them because it would take forever. You would just have these pre-done. So that's 4 and 4 is 8, 9, 10, 11, 12, 13, and so on. So step number 1 they want me to do is develop the sequence 4, 7, 10, and 13. So is it arithmetic? Is it geometric? Now this could be a problem in itself. Find the next term, and you're going to say, wow, I don't have enough little sticks. I don't have enough little papers. And maybe the two groups could join together. Here, lend me some of yours or whatever. And so you see the pattern. So what we're doing here, if I'm doing this, I am subtracting 7 minus 4. I need to find the difference. So 7 minus 4 is 3. 10 minus 7 is 3. Where's that 3? Remember that as I built my square, I have to add 3 more. 1, 2, 3. Every time I add another section to this pattern here, I'm adding 3 more sides. So it's plus 3, another 3, plus 3, plus 3. So my rule here is to add 3. Okay, so maybe the question would be find the next number. How many sticks would it take? How many matchsticks would it take for the very next problem? And so this one would be our question mark. Or maybe the next 3, and so on. Okay. Let's go ahead and develop this matchstick problem even further. What if they want me to find the 10th term? Okay. Find how many sticks, matchsticks, are needed for the 10th figure. Now here, as the students are doing these, you may have them glue them on a poster board that you have in your classroom. You have them glue them on construction paper or bulletin board paper that every school has some by the rolls. And you may want to combine with another group. But you know, we're going to get to the point where we're going to run out, where it's not feasible counting all the little sticks. And so we're going to rely on our formula. It is an arithmetic sequence, and so the formula we're going to use to find the 10th term is a sub n is equal to a sub 1 plus d times n minus 1. Okay, let's write that over here. A sub n is equal to a sub 1 plus d times n minus 1. Okay, let's identify our variables here. We are looking for the 10th term. We know that the first term was 4. And let's see, D. D is equal to, what was our rule? Add 3. So n is equal to 10 because that's what the instructions are asking for, the 10th figure. A sub 1 is the first term in that pattern in our sequence, which is 4 here. And D, the difference between the first number and the second number is 3. So that's D for difference. Okay, let's go ahead and plug it in. So A sub 10 is equal to A sub 1 plus D in parentheses 10 minus 1. Now remember our order of operations. PEMDAS, P-E-M-D-A-S. Or the way we say it in elementary is, please excuse my dear Aunt Sally. So in order to follow the correct order of operations, we start with inside our parentheses first. So we're going to do P for inside our parentheses. We copy everything else down, and 10 minus 1 is 9. The second thing we do, there are no exponents, and so we're going to multiply. In this case, parentheses means to multiply. So 3 times 9 is 27, and the last thing we do is add. So 27 plus 4. Remember to always write our answer in a complete sentence. Or 31 sticks are needed for the 10th figure. I think I should have written it that way. In the 10th figure. Okay. Now, if you remember, we did the UPSC. We didn't do the UPSC method to solve this problem. However, the very last step in any problem should be to check your work. Are the students convinced? So can you imagine how much fun it would be if now we had 2 or 3 students work together? Let's see, if everybody has 10 and there's 31, so it'd have to be groups of 3, and they would sit there and glue the pattern and count the number of sticks. I want to prove to them that it takes 31 sticks. And this way, it is reinforcing the concept of the formula, which is abstract, but we're reinforcing it with a concrete object. In other words, I can count the little sticks, and I want to make sure that it adds up to 31. Plus, it gives them something to do. And then you can put it and have them create a poster and display it on your wall. Okay, so let's go ahead and check this. We said the first one was 4, 7, 10, 13, plus what are we adding? We're adding 3, 16, 19, 22, 25, 28, I better be doing this right, 28, 29, 30, 31. Let's see if that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So here we checked it. Okay. So let's go back up to the heading here. And what we did was we created a matchstick problem. I'm going to call it activity. Matchstick problem activity. Now again, we're using the term activity to represent something that we can do above and beyond simply solving the problem. Imagine this problem, get a scratch sheet of paper here. Imagine if I gave you this problem right here. Find the next 3 terms. Or what if I asked you something like this? How many did we have? 4 of them, right? Find the 10th term. And we see these problems in the homework, and there's nothing wrong with problems like this because the students need practice. We need practice. But just think how much more interesting it is, something as simple as converting it to matchsticks, well, not matchsticks, sticks, little pieces of paper, and now you've turned it not only into a problem, but we converted it to an activity, and that's very important. If you're being observed this day in your class by your principal, do you want to have them observe you do 20 of these or 10 of these? You know, it's like, okay, I mean, yes, it's your topic. That's your SLO or student learning outcome that you have to cover for that day, which is perfect. But imagine just by getting little strips of paper, how much more interesting it is. Okay, so let me go ahead and wrap this up. We were doing patterns and sequences. We did a matchstick activity, but I want to go ahead and take a few minutes, probably outside of class, and I want to glue these, and I may have to cut them down so that it will fit. Okay. So anyway, we can do that. Let me at least glue one set. So remember in our supplies, now of course I'm not going to give my students teeny tiny little sheets of paper, but I only have this much room, and I told myself I could only use one sheet for this activity. Come on. Of course it's not going to work because y'all are watching. There we go. And you get the idea. There we go. Now they're not perfect because I just cut them. It's okay. That one looks like it's going to fall off here, so let me fix it. That one's too long. There we go. Okay. There we go. And I still have room for one more, which I'll glue later. So here we did a matchstick activity in which we turned a simple pattern problem. We still showed our work using the formula. This was my SLO for today. This was my learning objective. However, by using little sticks, we were able to, or little sheets of paper, we were able to turn it into a hands-on activity. So let's go to the back of our notebook and let's go ahead and write that up real fast while it's fresh in our mind. Let's go ahead and do our reflection on this. So don't forget to put a date across the top. You should probably be on page 4 already. I'm on page 3 because I don't write down everything you do. But today we did a matchstick activity. There we go. Matchstick activity. So let's go ahead and talk about what we did. So we were able to turn a simple pattern, an arithmetic pattern, into an activity by passing out to the students little sheets of construction paper or perhaps popsicle sticks or whatever we can think of. Let me see here. So we converted, not we, right, the book did, but we converted an arithmetic sequence into an activity in which we glued strips of paper to form the pattern. How's that? To form the pattern. Why? Pattern. So that's the important part. Why? Why would we do that, take that effort? I had to go find some paper. I had to go to my cutting machine at work, sit and cut there and cut and cut and cut strips of paper into little, I'd give the kids a little bit bigger ones, and then have them either glue it on a poster board or on a large sheet of paper. One, it's very good as classroom decoration. You know that in open house, you like to see stuff along the walls, right? Do you know that in some schools they even put decorations now in the hallways? And the poor math teacher has like, what do I put up? I remember my principal would tell me when I taught middle school, you need to decorate your room. And I'm like, I had the typical sunflower for the Fibonacci sequence, but I couldn't think of anything else. So having the students glue them and then you can put them up, and that would be incredible. Okay? Something to illustrate. So our main idea behind this, or goal behind this, is to engage our students. So let's look at some buzzwords. Engage our students. It's hands-on. Hands-on. Right? Hands-on means something that you're that you're doing, you're coloring, you're gluing. My granddaughter's in pre-K and they get pieces of Play-Doh and they put the pieces of Play-Doh down and then they count the little balls of Play-Doh. Yes, you can count, but it's much more fun to count the little balls of Play-Doh that you're making, right? So it's hands-on, it's engaging. What else can we write? Okay, so the goal of this activity was to engage our students by creating a hands-on activity that actively engaged, I just said that actively, we created a hands-on activity that actively engaged our students. There we go, let's write that down. It's a hands-on activity that actively engaged the students, or our students. And that's what we're looking for. There we go. I had to think of these terms to write my sentence, and that was our goal. Oh, we forgot to do a reflection. So what did you think about this? And it's so simple. I think it's so simple as little strips of paper, and you can just imagine the kids in your classroom. They're sitting there, they're gluing, and they're doing something rather than just sitting staring at the wall. And so I think it was a good idea. So go ahead and finish up your reflection. Give me a sentence or two on why you think it's a good idea. So go ahead and pause the video if you need to finish that up. So we already did an example using the arithmetic sequence to finding the nth term. We have the geometric one, and there's one more formula that I want to give you. Okay, so let's go to page 12 and let's go ahead and add one more formula that we need to know. And so we have here, to find the sum of an arithmetic sequence, we're going to use the formula S sub n is equal to n times a sub 1 plus a sub 2 all divided by 2. Now we could, instead of putting it all divided by 2, we can separate the 2 and put it in the front, and that would be n over 2, same thing. And in this formula, we are finding the sum. Let's say I've got 10 numbers, and I want to find the total. Or maybe I want to know what is the total. If I wanted to make sure that I had enough little sheets of paper and I wanted to find the total, I want to add 4 plus 7 plus 10 plus 13 so that I can make sure that I have enough. Let's go ahead and do this problem right here. So I'm going to leave my formula here because I still have one more formula to put over here. So let's go to, now let's talk about what happens if you run out of room. Now some of you may still have room on page 13, and I knew this was going to happen, so I have a little sheet of paper here. So what we should do is we should always have sheets of paper ready in case we made a mistake, or maybe we wrote too big. And you say, most of you write a lot smaller than me, so you usually don't have this problem. But what if you ran out of room and you say, man, I don't have any room on page 13 to even glue this? And so we're going to have little sheets of paper saved in the front pocket of our notebook. They could be a half sheet like this. Here's one that I wrote on, but you know what? I can still use it anyway. Sometimes I just need a little bit more room. And so I'm going to save these little sheets of paper in the front. Now I haven't put a pocket yet in our notebook, but I will in a minute. So here's an example of a pocket from another notebook. And what I did was I glued it along the edge. And this way I'm going to keep my scrap sheets of paper in the front pocket. So whenever I need one, maybe I can use color sheets of paper if I want to highlight something. So let's see what I have here. So I don't know if I need a whole half one, but it's okay. I'm going to save them anyway. And so what I want to do, I don't have any more room on page 13, but I want to find the sum. So I'm going to do it on a separate sheet of paper, and I want you to try it anyway, just so that you'll have an example in your notebook. Okay, so find the sum of the first, we have 4 of them, 4 terms, and we're not going to cheat and add them all up. So my pattern is 4, 7, 10, and 13. Now, of course, on the test, they're not going to give you a small problem like this. On the homework, they're going to have huge numbers, but I just want to practice how many little sheets of paper or matchsticks would I need if I wanted to give enough sticks to my students in order to build this pattern, or little sheets of construction paper. Okay, we're not going to add 4 plus 7 plus 10 plus 13. I want to practice using our formula. Let me write it down. The formula is S sub n is equal to n times a sub 1 plus a sub n. Oh man, made a mistake here, didn't I? This is a typo, guys. A sub n. A sub n. Okay, so let's add whiteout to our supply. Sorry about that. And I see it on the screen. What happened? A sub 1 plus a sub n, and n being the number that they're giving us, in this case 4. Okay, let's fix that, please. Sorry about that. A sub 1 plus a sub n, all divided by 2. Okay, so let's go ahead and identify what we have here, what we need. We know that n is equal to 4, because that's what they told me, 4. We know that the first number, a sub 1, represents the first number in this term. In this case is 4. A sub n is the last number, or in this case, a sub 4 is the last number. So we need to know the first and the last. Okay, do I have them all? Let's see. Let's go ahead and set it up. So the sum of the first 4, S sub 4, is equal to n times the first number plus the last number, all divided by 2. Okay, so let's go ahead and do inside our parentheses first. 4 plus 13 over 2. Okay, now here I'm going to have to multiply across and then divide. So this is going to give me 17 times 4 is 68, divided by 2 is 34. Okay. Now, another way of doing this problem right here as we get ready for fractions, remember, is that we can cancel from top to bottom. So what I could have done here is I could divide 2 divides into 4 2 times. And then I multiply across. So 2 times 17 is 34 over 1. Okay, so we need a total of 34 sticks or sheets of paper, whatever you want to call it. Okay, let's go ahead and check it. So 4 plus 7 is 11, plus 10 is 21, plus 13 is 34. Okay, so I added 4 plus 7 plus 10 plus 13. Now you say that's a lot of work. I could have added them a lot faster, and I know that. This was just a quick example. But imagine if there were 100 terms, and we want to find the sum of the first 100 numbers, or something like that in that effect, okay? So what we did was we used our formula. Let's highlight our formulas here. A sub n. So what we did was we found the nth term. We found the 10th figure. How many sticks for the 10th one only? And then I was curious. I said, you know what? If I were to give everybody some matchsticks, don't give them matchsticks, little sheets of construction paper, how many would I have to put in a baggie? And so now I'm curious, and I want to add 4 plus 7 plus 10 plus 13, and we used this formula. So this is a bonus question. Okay, we worked it out, and it turned out that we needed a total of 34 sticks. Well, time to switch colors here. There we go. 34 sticks total. So maybe I'd give everybody 35 sticks in little baggies, and then they could sit there and have enough for this whole construction of the first 4 terms. Okay, so let's review here. What happened in this problem was that I knew I wasn't going to have enough space on my one sheet, and I only wanted to use one sheet of paper. I'm not allowed to go to page 14 because remember, my notebook has to last me the whole school year, and so I want to save paper. And I wrote too big, and it's like, what do I do when I write too big? So what I did was I extended my problem on half a sheet of paper, and this way what I'm going to do is fold it along the edge. Now if you didn't use the whole sheet of paper, then we can cut off some of the bottom, only use. So I'm going to fold a little flap, and that's where I'm going to glue it. Remember that we always glue in the center, if possible. There's going to be times where it's not possible, like when we did the earlier foldable, but whenever you have a single sheet of paper, always put it in the middle, in the gutter. If you put it on the outer edge, it's going to be sticking out, and it's going to be falling out of the notebook. So what I want to do here is go ahead and then glue it down. Now yours may only be 3/4 of a sheet of paper, or a little half, a little piece. Sometimes I just need like a little bit more space. I kind of gonna cover it a little bit, so it's okay. There we go. So you do this anytime you need additional space. Maybe you made a mistake and you had to cross it out and you needed more space. So All I did was I added on a little sheet in the center, and now I can continue my next lesson on page 14. There we go. So that's kind of cute. It's a great idea for our composition notebook. Okay, so let's go back to that page. Where is it? We're on page 12. We have the formula for the nth term, arithmetic, geometric. We haven't done one of those yet, that's okay. And now we found the sum. So let's look at one more type of sequence in which it is called successive differences. Now I don't have a lot of space, so I got to make sure it fits. Now, in this type of pattern called successive differences, the pattern does not appear until the second row. So let's go ahead and subtract here to see what is happening. So 6 minus 5 is 1, or 5 plus 1 is 6. Remember, I get the number on the right and I subtract it from the number on the left. So 14 minus 6 is 8. 29 minus 14 is 15. 51 minus 29 and 80 minus 51. Well, that's not an arithmetic sequence. It's not, because look, I have different numbers. But let's subtract one more time and then you'll notice the pattern. 8 take away 1 is 7. 15 minus 8 is 7. 22 minus 15 is 7. And 29 minus 22 is 7. So this is called successive differences. Let's switch colors here. Successive differences. So let's continue this pattern. Let's put a box here. What would be the next term? We know we're adding 7 to the bottom, but you need to start on the bottom and build your way up. So 29 plus 7 is 36. And now I add 80 plus 36. Okay, let's do that one more time. I have room there for one more step. Okay. So there we go. Just enough for one more. So this is a 36 and a 116. Okay, so let's give you a second to try that. Start on the bottom with the 7. So we're going to add 36. So 36 plus 7 is 43. And now I'm going to add 116 to the 43. With our last problem, on page 14, let's go ahead and copy the arena problem. We will need a full sheet of paper. Okay, so the first row of seats in a section of an arena has 7 seats. There are 2 additional seats in each row. There are 25 rows in the section. How many seats are in the last row of the section?
Remember that if you need additional time to copy down the problems, feel free to pause the video. Okay, the instructions say for us to solve this problem using the UPSC method. So what I'm going to do is I'm going to draw a large plus sign across the rest of the paper, which would represent my box. We're going to identify the different sections as U, P, S, C. Okay, let's look at the first one, which is U for understand. So if you were reading this problem, you would ask your students to underline key important information. We are not going to copy the whole word problem over again because we already have it here. So we know that the first row of the seats in a section of an arena has 7 seats. So that's important. So there are 7 seats in the first row. There are 2 additional seats in each row. Okay. There are 25 rows in the last section. In the section. There are 25 rows in the section. How many seats are in the last row? So we're looking for how many seats. In the last row. Okay. An important point that we must not forget is looking at the vocabulary used in the word problem. If you'll notice, the first row of seats in a section of an arena. I'm going to circle that so you could see that. An arena. There may be some students who don't know what an arena looks like. So I did find a picture here. Let's see if I can pull it up. Oh, there's my UPSC chart, similar to what we're doing. And there's my arena. It's not the best. It looks like an auditorium or something. But anyway, I wanted to show that the first row is smaller, and then it's longer, the second one, and the third one's even longer and longer until you go all the way to the back. So that's what I want to show, or I'm trying to show here. And so we may want to draw a little sketch of an arena. We may want to explain that the first one has 7. And then we're adding 2, kind of small there. Let's make it a little bit larger. But you get the idea. And so that we are adding seats to each one. Adding 2. And so on. So I would kind of make sure that I explained what an arena, and probably do a little bit better job with the drawing. Okay, let's talk about plan. So let's go ahead and plan here. What strategy are we going to use? Now, my objective for this lesson is to use the different formulas that we have available. So let's go ahead and open that. Now, we saw in the previous lesson that we have the formula for the nth term. It's arithmetic, so we're not using the geometric. And this formula down here is the sum. If I were to add all the seats in the auditorium from the first row to the second row plus the third row, I would use this formula. But we are looking at just the 10th row. So we're using this formula. So let's go ahead and write that down. So our plan is to use the formula. So we're going to use the formula to find the 25th row. To find the number of seats in the 25th row. Okay. We also need to have, we need to identify some of these terms. So maybe we need to start our pattern off. And we know that we started off with 7. We added 2 more. Okay. Now in S is where we actually solve it. Now I'm going to recopy my formula because it's way over here. So I'm going to bring it down. So I'm going to recopy my formula and identify each term. Now we know that N is 25 because there were 25 rows. We know that there are 2 additional seats in every row. And what else? Oh, A1, A sub 1 is the first one, which is 7. So A sub 1 represents the first number in our sequence here, 7. The first row had 7, and then we added 2 to every row, so that's D, and we're looking for 25 rows. Okay, so let's go ahead and work out our problem. We know that A sub 25 is equal to the first number 7 plus 2 times, in parenthesis, N, which is 25 minus 1. Okay. Now, according to our order of operations, remember we do inside our parentheses first. So 25 minus 1 is 24. Next, we multiply. So 24 times 2 is 48. And then we add the 2 together. Let's write our answer as a complete sentence. There are 55 seats in the last row. And that's my answer. Now notice that as a future teacher, I need to make sure that I show my work neatly. I always recopy the original formula. I label each part, each term of my formula. And notice how I show my work step by step by step. And we write our answer as a complete sentence. Neatness and completeness is important. Now to check my work, I can't think of another way of doing this, so I may want to just double check the problem. Maybe I would work it out again, but you know, I could. It's kind of crazy, but let's just go for it. Let's see, 7. Are we there yet? 41. And there we go. And I would count them to make sure that there's 25. 25 checks. So there are 55 seats in the last row. Okay, in summary, we had a word problem that happened to have a pattern in it. And so I wanted to practice not only, of course, our formula, but I wanted to practice setting up the UPSC method. Sometimes it's called UPS check or UPSC, in which you draw the giant square on the bottom, and we did the divided into 4 sections. Okay. I hope this example has helped you.